space, signals, and matter. In this series, we are trying to understand the true complexity of galactic energy patterns. We explored the idea that space may be part of the larger system, not just an empty background where things happen. We also looked at how galaxies are filled with signals moving through space, creating dense, information-rich environments. But now we arrive at another important piece of the puzzle. What about the matter sitting inside all of those environments? How does matter respond to complex environments? Matter is already complex. At first glance, matter can seem simple. Stars, gas clouds, planets, and dust all appear to follow the same basic gravitational rules. But when we zoom in closer, matter becomes far more complicated. Atoms are not tiny solid balls. They are highly structured systems made of interacting components and energy states. And those systems constantly interact with signals and conditions from their environment. If atoms are already understood to be highly complex systems, then should we assume that simplified gravity models fully capture how matter behaves inside high information density galactic environments? Signals must be processed. A signal by itself does nothing unless something responds to it. In order for matter to react to gravity, electromagnetism, or other environmental inputs, those signals must be processed by physical systems. Matter itself is the physical system that processes that information. We should stop to consider how matter may process signals under different conditions. This may become important when we try to model large and complex systems like galaxies. Local environments change behavior. In many systems, behavior changes depending on the environment. Modern physics already shows that matter can respond differently under different conditions and configurations. Temperature, pressure, density, and electromagnetic activity can all influence how systems behave. Therefore, the effect of local environmental conditions should be considered in our models. Mapping local temperature, electromagnetic activity, pressure, density, and gravity signals in conjunction may reveal hidden patterns that help improve our galaxy models. Matter has constraints. Matter is often treated as if it responds perfectly and instantly to every signal it receives. But in information systems, processing always requires resources, and resources are limited. If matter is constantly interacting with signals from its environment, then different regions of a galaxy may place very different demands on those systems. Dense regions with many overlapping signals may create very different conditions than quieter regions near the outer edges of a galaxy. So instead of assuming matter always behaves the same way everywhere, we can begin asking whether local conditions and processing constraints may influence how matter behaves inside these large-scale systems. An information systems approach. In this series, we explored several complex systems that may deserve deeper investigation and more detailed models. And if we begin adding back manageable incremental layers of information complexity, we may discover new relationships, feedback loops, and cause-and-effect patterns that help expand our understanding of physics. That is the information systems approach, explored in Darwin's Machines, 2024, where complex systems are viewed as systems that store, process, and transmit information. Please see the links below if you would like to buy the book and take a deeper dive into modeling complex systems through the lens of information systems.